This Lesson 103 assignment will demonstrate how to use PIO state machine interrupts to communicate between the four state machines on a PIO block. We will create a state machine program to raise IRQ0 when the red push button is pressed, IRQ1 when the yellow push button is pressed, and IRQ2 when the green push button is pressed. We will also create three smaller state machine programs. Each program will monitor a particular interrupt, toggling the appropriate LED when that interrupt is set, then resetting that interrupt. State machine interrupts do not cross back and forth between PIO 0 and PIO 1, so all four state machine programs must be on the same PIO. This puts a 32-line limit on the total number of executable lines of code that we can use. Here's the code. Our program starts with imports as usual, pin because we'll be using the pin statement, and RP2 because we're creating state machine programs. We'll begin by explaining the toggle red routine, which starts on line 33. The routine starts by setting the X register to a value of 0. Passing through the wrap target, the program stalls at line 35, waiting for IRQ0 to be set. IRQ0 is set in the capture buttons routine whenever the red push button is pressed. Once IRQ0 is set, the toggle red routine inverts or toggles the value in the X register on line 36 and copies that new X value to pins, that is the red LED, on line 37. Finally, the toggle red routine clears IRQ0 on line 38 and wraps back to wrap target, after which it stalls once more, waiting for IRQ0 to be set again. The toggle red routine is comprised of 5 executable lines of code. The toggle yellow and toggle green routines are also 5 lines long. These 3 routines are not identical, so all 15 lines of executable code contribute to the total number of lines used. Given the 32-line limit for the total code in each PIO, that leaves only 17 lines of elbow room for the capture buttons routine. The read buttons section of the capture buttons routine starts by copying null into the ISR to eliminate any prior data in that register. Line 12 shifts the 3 bits representing the current status of the red, yellow, and green push buttons into the ISR. Notice that we do not debounce the push buttons with no op31 statements as we have in previous lessons. I confess that I do not really understand how delaying execution after pin status has already been shifted into the ISR helps to debounce the switches, and leaving the no ops out saves us a few lines of precious code. Line 13 copies the ISR data to the Y register so that it can be used later in a comparison statement. Notice that we do not check for unpressed buttons in this routine. This is another attempt to reduce line count. Unpressed buttons will fall through the logic and eventually take us back to read buttons from line 26. The Is It Red section starts by setting the X register to the binary pattern 001. This is the pattern corresponding to the input status when only the red push button is pressed. Line 16 compares this pattern to the actual input pattern stored in the Y register. If the patterns are different, we know the red button was not pushed by itself, and we jump to the Is It Yellow section of the program. However, if the red button was pushed, X will equal Y, and execution will fall through to line 17, which stalls the program waiting for the red button to be released. Once the button is released, line 18 will raise IRQ0 and stall the program again, this time waiting for IRQ0 to be cleared. As we have seen, the toggle red routine will clear IRQ0 once it has toggled the red LED. Notice that when IRQ0 is cleared, program execution continues from line 18 down to line 21, where it jumps to the Is It Green section of the routine. When execution reaches line 26, we loop back to read buttons. This approach takes a little longer, but it saves us 2 jump to read buttons instructions, which would put us over the 32 line limit. The is it yellow section of the routine operates in a similar way to is it red, with the exception that it controls IRQ1 and interacts with the toggle yellow routine. The is it green section follows the same design, controlling IRQ2 and interacting with the toggle green routine. Here we can see the definition of our push buttons and LEDs, the instantiation of all 4 state machines, and the standard try except clause with an empty while true loop. And here's how it works. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.